Hello everyone, welcome to Aryan tutorials on engineering mechanics. So in this video, I would like to explain about simple screw jack, which is basically used for lifting heavy loads by the application of the simple effort. That means minimum force. By the application of minimum force, we'll be lifting the heavy loads. So that is only the application and advantage of the simple screw jack. Okay, this is one of the machines which is used for lifting the heavy loads. So first I would like to give the definition for a simple screw jack. What is a simple screw jack? So a simple screw jack is a device or a machine which is used to lift heavy loads by a small effort. Small effort means by using a small force, and that means the force less than the load we are going to lift. Okay, with a mechanism of screw and nut. So basically, screw jack works based upon the screw and nut mechanism, but the principle is different here. So the screw jack works on a principle of inclined plane. Okay, here the mechanism is screw and nut, but how this mechanism is obtained means by the principle of inclined plane. So how can we say that it works on a principle of inclined plane means with reference to the helix which is formed on the threads of a bolt. Okay, now so that is formed by the principle of the inclined plane only. So how can we say that means here I would like to show a simple diagram. So assume this is a bolt here, okay, and this is an inclined plane which is having the edge at a particular angle theta or any particular angle assume. So this is inclined plane. So when you assume at the edge of the inclined plane there is a thread is there. If you slowly wound the thread on this bolt slowly like this, like this, like this, like this. So at the end of it, so the thread is wounded according to the inclined plane on the bolt. So it is forming a helix. Okay, now so that helix is obtained on the bolt with reference to the inclined line only. Okay, now so that's why we can say that it works on the principle of inclined plane. So this helix in the form of helix only will be making the threads on the bolt. So based upon that and that only upward and downward movement of the bolt inside and nut takes place. So which again based upon the inclined plane only we got that motion for the bolt. Okay, so that we can say that screw jack works on a principle of inclined plane. Okay, so next I would like to show you. So this is the simple screw jack. Okay, which consists of a basic nut, okay, with two supports or any two or three supports. Okay, so which forms the main body of the screw jack, that we can call it as jack. Okay, jack body. Okay, so nut is provided with internal threads. Okay, in that nut a main screw is inserted into it, which makes upward and downward movement in the nut. So based upon the threads, external threads we have provided for the screw, and this screw, the top of the screw is provided with a screw head on which a heavy load we can place it. Okay, so by placing the heavy load by rotating the screw with the help of the lever here, this is the lever or handle we can call it as. So by applying the force at the end of the lever by rotating the screw, okay, now we can get the upward and downward movement for the screw. So based upon that, again the upward and downward movement of the load which we are going to place on the screw head will be taking place. So the moment to the load will be applied based upon the rotation of the screw with the help of the lever. Okay, this is the simple screw jack with all the parts. So next I would like to assume certain elements on the diagram to analyze the performance of the simple screw jack. Okay, analysis is very important to analyze the performance of the screw jack, whether it can lift heavy loads. That means whenever it is capable to move or lift heavy loads, then only the advantage is more for the simple screw jack. Okay, so to analyze that performance, we have to give certain relations in the form of the formulas by assuming certain elements on the diagram. Okay, so the first thing is L is, I want to assume L, which is the length of the lever arm, okay, or handle. Okay, so which is from the center of the screw to the end of the handle or lever arm. And next I would like to assume P is the pitch of the screw. Okay, the screw thread, that is the screw we have inserted into the nut, both will be having the same pitch only. Okay, so the pitch of the screw I want to assume as small p. Okay, and again the pitch definition, you should know what is the definition of the pitch. The definition of the pitch is it is a successive distance between the two uh, crest points or trough points. Okay, now the distance between two successive crest or trough points of the thread profile is defined as the pitch. Otherwise, in another way, we can say that for one rotation of the screw, how much the distance it has moved, either upward or downward, that distance moved by the screw is called as pitch. Okay, this is only for single start thread. So in single start thread, for one rotation of the screw, it will move equal to the pitch value of the thread. But actual definition is it is the distance between the two successive crest or trough points of the thread profile. Okay, so remember the definition for the pitch, two definitions. And next I want to assume capital P. Okay, here the capital P is the effort or force we will be applying for rotating the screw for lifting of the weight. Okay, next similarly W, assume the W is the load that which should be placed on the screw head to lift it. Okay, so these are the elements you can assume. So next we have to know what do you mean by mechanical advantage and velocity ratio, which are useful in analyzing the performance of the screw jack. Okay, mechanical advantage. First I would like to tell you what is the mechanical advantage. Okay, mechanical advantage is defined as the ratio of MA. In short form we can represent it as MA, mechanical advantage. So it is defined as the ratio of load lifted, which is the W, to the effort applied. Okay, now load lifted to the effort applied, the ratio of load lifted to the effort applied is called as the mechanical advantage, that is W by P, as we assumed the elements, that is the load to be lifted and the P is the effort to be applied for lifting the load. Okay, that is about the mechanical advantage, one of the elements. Okay, and next I would like to tell you about the velocity ratio, okay, which is also important in analyzing the performance of any simple screw jack. Okay, so velocity ratio, again in short form we can write it as VR. So this velocity ratio again defined as the distance moved by the effort. So during the rotation, okay, here by at the end of the lever you will be applying the force to rotate the screw. Okay, during that rotation, how much the distance moved by the effort. Okay, now distance moved by the force that we are applying at the end of the lever. Okay, so ratio of that distance moved by the effort to the distance moved by the load. Okay, now so it is the ratio of, during the lifting of the load, it is the ratio of distance moved by the effort in a circle manner and the distance moved by the load in upward or downward direction. So that is called as velocity ratio. Okay, in short form we can write it as the distance moved by the effort. How can we write it as distance moved by the effort? Means assume here by applying the force we have completed one revolution. Okay, now one revolution means it can form a circle with a radius of equal to the length of the lever. Okay, so L is the radius of the circle which is formed by the rotation of the lever. Okay, by which is obtained by applying the force. Okay, now so that means here when it is completing one revolution means the distance covered by the load can be equal to the circumference of the circle. Generally circumference of the circle means it will give you the length of the circle. Okay, now similarly the distance traveled or distance moved by the effort means equal to the circumference of the circle formed by the revolution of the lever. Okay, so that can be written as, according to the radius, the formula is 2 pi r. So in place of r we need to take 2 pi l. So 2 pi L by distance moved by the load in upward direction. So here we are completing one rotation. So similarly the screw also completes one rotation. So when the screw is completing one rotation, how much the distance can be moved in upward or downward direction means here that will be equal to the pitch of the screw. Here the distance moved by the screw in upward in linear direction is equal to the pitch. Why? Because the pitch definition itself, for one rotation of the screw how much the distance it is moved is called as a pitch. So similarly we are completing one revolution means the screw also moves equal to the distance of pitch. So the distance moved by the load is ultimately equal to the pitch of that screw. So the velocity ratio we can write it as 2 pi L by P. Okay, circumference covered by the lever to the distance moved by the screw which is equal to the pitch value. Okay, so by these two we can find the efficiency of the screw jack. Okay, now efficiency, how much the efficient, with how much efficient it can lift heavy loads, that also we can find out with the help of the mechanical advantage and the velocity ratio. So here the efficiency of the screw jack is defined as the ratio of eta. Eta is defined as the ratio of mechanical advantage to the velocity ratio. Mechanical advantage by the velocity ratio is known as the efficiency of the screw jack. Okay, that is about the uh, terms related to the analysis of the performance of the screw jack. Okay, now one is mechanical advantage and another one is velocity ratio and third one is efficiency. Okay, so these are the three terms important in analyzing the performance of the simple screw jack. So next we try to discuss one problem. Okay, the problem will be given like this here. A screw jack has a thread of 10 mm pitch. Here the pitch value for the screw is given as 10 mm, and what effort applied at a handle of 400 mm, that means the lever arm length is given as 400 mm long, will be required to lift a load of 2 kilonewtons if the efficiency at this load is 45%. Here he is asking what effort applied or what effort will be required to lift the load of 2 kilonewtons if the efficiency of the load is, if the efficiency at this load is 45%. Okay, he has given the efficiency eta and the load to be lifted and the length of the lever arm and the pitch value of the screw. Then we need to find out what is the force required to lift the load. Okay, now so now we try to write all the elements given in the problem. Pitch value P is equal to given as 10 mm, and similarly the length of the handle or length of the lever arm is given as L is equal to 400 mm, and the load to be lifted which is W is equal to given as 2 kilonewtons, which means 2000 newtons. And again the value of efficiency of the screw jack eta is equal to given as 45%. So in this we need to find out, so 45% means 40 by 100, 45 by 100, which give you 0.45. And here we need to find out effort to lift the load, which is P is equal to capital P. We need to find out with the given information. So in the next slide I'll write all the values given again, one by one: P value, L value, W value, and eta value. So one by one we try to find all the elements, mechanical advantage and the velocity ratio and the efficiency. Finally we will be getting the required value, capital P. Okay, that is only we need to find out. Next, first I would like to write the formula mechanical advantage, which is defined as the ratio of W load to be lifted by effort applied to lift the load, W by P. So W value is given as 2000 newtons and the P value we need to find out, which should be the unknown element here. So keep the relation like this only. Next go for velocity ratio, which is defined as the ratio of distance moved by the effort, that is equal to the circumference 2 pi L by the distance moved by the load, which is equal to the pitch value. Okay, so 2 pi is constant, 2 pi into L means L value is given as 400, substitute 400, and the P value is given as 10 mm, substitute 10. Okay, all the dimensions are in mm only. Okay, so finally we'll be getting the value as 251.3. The velocity ratio is a pure number, which is the dimensionless quantity. Okay, na? So both are above and below, both are in mm, so mm gets cancelled, so we'll get the dimensionless quantity. Here also mechanical advantage, also ratio of two loads, both will be in newtons only. So again the pure number, which is the dimensionless quantity, we'll be getting for these two. So now I would like to write the efficiency formula, which is defined as mechanical advantage by the velocity ratio. So try to write those values we got in the above steps. 2000 by P whole by 251.3. So try to modify this form. We'll be getting 2000 by P into 251.3. So in the next slide, so the same step I'm representing here. So next I would like to modify this one. The efficiency is given as 0.45, so that should be equal to again 2000 by P into 251.3. okay, so take the P to the left side and 0.45 to the right side in the denominator. So P is equal to becomes equal to 2000 by 0.45 into 251.3. So by modifying by using the calc C, the P value will be getting as 17.7 newtons. So to lift the load of 2000 newtons, we need 17.7 newtons, which is less than the 2000 newtons, by operating the simple screw jack with the given dimensional values. So this is the way of calculating for a simple screw jack. I hope you understand the working of the simple screw jack, okay, and how to solve the problems on the screw jack. That is only simple screw jack. In the next video you will find how to analyze the differential screw jack, which is also used to lift the loads only with the minimum effort again, which is the improved form of the simple screw jack. Okay, so next video I explain you about the differential screw jack. Please wait for that. And once again, thanks for watching my video. If you still have not subscribed to my channel, please subscribe to my channel and share my videos with your friends. And once again, thanks for watching my video. Thank you all.